what is unusual about the results for X-ray diffraction for the sample holder? For the sample holder in particular, you should have seen that number one, the detected elements were strange. They were things like, I don't know, maybe tungsten, or that's not that strange, but I think the detective elements were really not what the sample holder was made of. They were not what's typically in a polymer, and you could tell that the sample holder itself was a polymer. So why is that? So we are expecting to see things like carbon, hydrogen, maybe oxygen. These are small atomic number elements, and typically these do not emit X-rays, characteristic X-rays. They emit instead in the process of, let's see, if you only have a couple of shells, when you knock an electron out of this guy, let's see, carbon is, 2 shells. Let's see, 1, 2, 3, 4. So if you were to knock an electron, one of these guys, out of here, you have an empty space here. Electron drops here. It's the energy difference of these two levels is not very high, but it's enough energy to maybe, instead of giving off a photon, giving its energy to this guy, and this guy jumps out, and this is called an Auger electron. So this is an electron transition results in kicking out an electron, not actually emitting an X-ray. So that's why these light elements are typically not detected, because this process is more likely with small atomic numbers. That's what accounts for that. The practical implications are, obviously, these are not, they're not going to absorb X-rays, which could be good because, you don't want to have X-ray absorption from the sample holder, and you don't want to have X-ray fluorescence from the sample holder. So that is a positive implication of that. I guess the negative implications might be that, plastic is not going to protect you from X-ray exposure. The second thing that was unusual about the results is that, of course, they did not sum to 100%. And this is, again, an artifact of these light elements not being detected. What you did see there were trace amounts, like quite literally, I don't know, 0.001%. This is below the detection limit of this technique. Particularly detection limit, particularly for the XRF gun. This is done in air, and air can be ionized by X-rays. When you do an analysis, let's say in a vacuum, you can actually detect the presence of these lighter elements. X-ray fluorescence is possible. It's less probable, but it does happen. And so in a vacuum, carbon, at least, and oxygen can be detected. But with the air gun that we have, you can't actually get these elements.